A very warm welcome to my dear friends and students. A very good morning, good afternoon, good evening to all of you. And as you know, this is the DADM 2 lecture, which is Data Analysis and Decision Making 2, and this is lecture number 5. And this whole course is for 12 weeks, which is 30 hours. Each week we have 5 lectures, and after each being lecture being for half an hour, and after each week we have an assignment. So, we will be wrapping up week 1 and we will have assignments based on assignment 1. Then similarly, once we finish any week, we will have assignment based on that week and proceed accordingly till we have the final examination. And I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we initially in the last 2 classes, I will just wrap it up within 2 minutes and then recapitulate and then proceed with lecture number 5. So, we had 2 different concepts, which was basically relative risk aversion and absolute risk aversion, and these properties were basically, which I mentioned, was theoretically they have some formulas, and I must just give the background based on which you can basically prove it. But their actual utilization, I said, would be coming up later on, and for the quadratic utility function we did prove. I did not go through the details, but you can just simply do it by finding on the first differential and the second differential, that we find out u prime and u double prime, put the ratio which is u double prime divided by u prime with the minus sign, find out a, then correspondingly find out a prime. So, similarly find out r and r prime, and then comment on the this absolute risk aversion property and the relative risk aversion property with respect to whether they are greater than 0, equal to 0 and less than 0. Based on that, we can say that it is that quadratic utility function or whatever the utility function is, which I am mentioning that all the utility functions would have properties based on a prime and r prime, and they would be distinct. So, based on that we can comment. So, let us further continue the discussion with other 3 different utility functions, which I had briefly mentioned. So, the first we have already done, which was quadratic utility function, then there would be power utility function, exponential utility function, and logarithmic utility function. So, now for the quadratic utility function, I did not wrap it up, the last stages were left. So, if you plot the Excel sheet which I just showed was basically the last slide which was there. In the first column you have the values of w, I took arbitrarily some values of w, then you have uw based on the value of b, that is a parameter which you had. Then in the next 2 columns which I did not write or did not explicitly show it, but I did mention that you find out the difference of u. So, that means u2 minus u1, u3 minus u2, u4 minus u3, that means 1, 2, 3, 4 these suffixes are corresponding to the time periods or which w values are there. You find it that in the third column. Similarly, you find out on the fourth column, again the fourth column was not shown there, you find out the values of difference of the values of w, that is w2 minus w1, w3 minus w2, w4 minus w3, and so on and so forth. Then we basically divide the third column values, respective values, with the fourth column respective values, and you find out u prime is the simple definition of differentiation. Then we have to find out the second differentiation, which will be basically now the differences of the third column, which is basically u prime values which you have. So, basically you find out the difference of u prime for the second period minus the u prime for the first period, then you find out the u prime for the third period minus the u prime for the second period, and go and so on and so forth. And then again you divide these values, corresponding cell value written in fifth column, by the corresponding values of difference of w's, that is w2 minus w1, w3 minus w2, so on and so forth, and you find out the u double prime. Once you find out the u double prime, then as per the formulas you can put it and find out a, then similarly you can put these values and find out r, and then again follow the same concept to find out the difference of a2 minus a1 divided by w2 minus w1, then find out the value of a3 minus a1 divided by a3 minus a2, sorry, and find out the values of W3 minus W2. Similarly, you find out the difference of R2 minus I1 divided by W2 minus W1, find out the difference of R3 minus R2 divided by W3 minus W2. That means, you are finding the differential such that you have A prime and R prime, and once you plot it, the values which you have in this simple graph, it is not possible to see the other values, but at least if you can see where I am just marking this. Let me use the color pink if it is available. Let me use the highlighter, it will be best. The orange one. So, this is basically the value of u, which is this. This is a quadratic one, if you can see. Then similarly, in the next, the index or the coloring, you have, I will just mark it. I will just put a tick mark. You have AW, which is in yellow, it is somewhere here. If you can plot it, it will be much better for you. Then the bluish green one is A prime, then the violet one is for R, and the brown one is for R prime. If you plot it, you will get the characteristics curves for this U A prime R R prime for the quadratic utility function. Then let us go to the logarithmic utility function, which is ln of W. And then if you want to find out A and R, again the formulas you will use would be, for A would be minus U double prime by U W, and for R it will be basically minus W into U double prime by W. Put those values accordingly, that means find out U prime and U double prime. For ln of W, U prime is 1 by W, and similarly for the value of U double prime would be minus 1 by W square. These formulas are very simple. You can check up any class 10 or 11 basic differential equation or basic mathematics book, and basically can utilize them accordingly. So, once you find out A prime and R prime, the values which are come out to be for A prime would be minus 1 by W square, and for R prime it comes out to be 0. So, if it is W is positive, so obviously square is also obviously a positive. So, A prime would be negative and R prime would be 0. So, we can immediately comment we use this type of utility function. That means, if we have this information, that is it has got decreasing absolute risk aversion property and constant relative risk aversion property, you can find out and comment that this is a logarithmic utility function. So, similarly, again now you should draw the graph. So, before that we will basically put the values in the Excel sheet, follow the same procedure as we have done for the quadratic utility function. So, this is also the Excel sheet based on which we can solve and at least draw the logarithmic utility function. The first column is the values of W. Again you can take any values of W. I have to make our life simple, I have taken the values as 1, 2, 3, 4, so on and so forth. They can be decimal also, and they can be any other higher values also. Based on that, I find out ln of W. Ln of W values are given in the second column, which is this, which is these values. Now, third and fourth column are missing, which I have not noted down, but I will just because it would have become too cluttered, but I will just mention it again. I may be going a little bit slow. I know that I am repeating few things time and again for each concept, but please bear with me. It will be much easier for me to follow a sequence, point 1, and repeating such things would definitely make things much better for you to understand. If somebody has understood that before and with one of my repetition, I would tell them to have the patience. So, let me go slowly and cover the concepts. So, if I basically use the highlighted yellow, so okay, I have to basically write down. So, what you will have here, one would be basically be, so these are the U's, the second column. So, technically I would have one column where I will basically find out U2 minus U1, then I will find out U3 minus U2 and continue accordingly. So, 1, 2, 3 are basically the time periods, and they are the values have been taken purposefully for our example as equidistance. There would be another column, and let me use a different color. There would be another column which would be the fourth one, which will basically have values of W2 minus W1. Then the next value in the cell corresponding just below that would be W3 minus W2. I will continue accordingly. So, this would basically be the fourth column values. So, these are the fourth column values and these are the third column values. Now, in the fifth column you will basically have A. So, A, how do you find out A? Use the formula minus of u double prime by u prime. So, how do you find out u prime? U prime would basically be the corresponding value of u2 minus u1 divided by w2 minus w1. Next value would be u3 minus u2 minus w3 minus w2. Next value would be u4 minus u3 divided by w4 minus w3. You find out those values. So, that would basically be the denominator for A prime A, and for finding out the numerator of A, again you find out the first differential of the third column values. That means the difference of this and this. Similarly, the difference of it will be basically u4 minus u3 minus of u3 minus u2. So, that would be give me those each corresponding cell values, again divided by this w values which I have. Utilizing that, you can find out the corresponding values of u double prime. Once you have the u double prime with the minus sign, as per the formula you find out A, then find out the first difference of the A values, divide by again the difference of w's, find out A prime, put in the formula of R, find out the R values, find out the first differential, that means R2 minus R1, then the next value is R3 minus R2, so on and so forth, then divide them by the corresponding values of w's, that means W2 minus W1, W3 minus W2, so on and so forth, find out R prime. So, if you notice then, as for the logarithmic one, R prime was mentioned is 0, we have calculated it. So, actually rightly so, the last column which is shown here comes out to be 0. And if you remember, for the values of A prime, we mentioned the values was coming out to negative. So, whatever value you take, you can just double check in an Excel sheet, the values really come out to be negative. So, with this we have been able to at least in a very simplistic sense check that the actual calculation based on simple mathematics or differentiation is being corroborated or double checked when we basically take very simple values of wealth and then put them in the utility function, which is logarithmic utility function, and check the values of A prime and R prime. Now, we need to draw the graph. I am going the same sequence of steps as I did for the quadratic utility function. If you draw the graph, put those values and then basically find out and plot the values of u, then A prime, R prime. You can check the values which are given. I will just use the highlighter of the green one. So, the pink one is u prime, I will just mark that. Then the yellow one is A, which is shown here. I am not going to mark it, but I am just going to move my pointer above that without marking. Then similarly, the bluish green one is A prime, which is also there. Then R and R prime are given here in these values, and they actually corroborate and double verify the fact which we have already discussed considering the simple differentiation. So, that completes this very simplistic way of trying to first do for the quadratic one, then the logarithmic one. So, we are left with two more utility function, and I will follow the same procedure. Maybe I am taking time, but that will definitely clear your doubts. The problems, okay, just I am not digressing, I am just changing the topic to some related for the assignments. For the assignments, there would definitely not be any diagram part. Let me make it very clear. So, it will be more conceptual part of problem solving. The problem solving which you remember, one of the problems which I solved was basically based on a person investing in a government security or government bond with respect to a non-deterministic one. There were 3 outcomes and each had a probability and you had a utility function. Though those type of simple problems would be coming, there would be other problems which I will discuss. So, concentrate on that. The reason I am going slow for drawing the diagrams for the utility function is basically to make you understand that what I actually mean by the concept of r prime, a prime, because for each utility function they would have some unique characteristics based on which you can basically immediately say that the utility function is either logarithmic or quadratic or exponential or power, depending on what are the characteristics of a prime and r prime. So, without much ado, let me continue with the third utility function. The third utility function is the exponential one. So, again if you put in the formula and find out the u prime and u double prime using the simple differentiation concepts, and if you put them in your equation, the value of a prime comes out to be 0 and the value of r prime comes out to be a is positive here. So, we use the utility function, and if we find out, we will immediately say that the absolute risk aversion property is constant as it is 0 by the first bullet point, and if I consider the value of a as positive, then r prime is a. So, hence we will say it is an increasing relative risk aversion property. So, if we rather than the utility function, if we had these properties mentioned to us correspondingly to the fact that r prime and a prime is either increasing or decreasing or equal to 0. Similarly, r prime has this property of either increasing or decreasing or equal to 0, immediately put them in the right context and basically can mention that what type of utility function it is. So, I will try to again go through the same sequence of steps as we did for the quadratic utility function and the logarithmic utility function. You plot the values of w in the first column in an Excel sheet, put the values of uw is basically that exponential utility function with a certain value of a. Let us not be too much bothered of a would be 0.25, but what I am trying to highlight is that how you draw the graphs in order to basically make yourself very acquainted in a very simplistic and practical sense that how the utility functions can be plotted. Then again in the third column, I am not going to write much in this slide, but again explain to you. So, if you listen to me, you will definitely understand. In the third column, you will basically have the difference of the utility functions, which is u2 minus u1, u3 minus u2, so on and so forth. In the fourth column, you will have the difference of the w values, which is given in the first column. So, it will be w2 minus w1, w3 minus w2, and based on that, once you are able to find out u prime. Once u prime is found out, then you will basically find out the first differential of the u prime values. That means it will be u3 minus u2 minus in the bracket u2 minus u1, continue in this way, and then divide by the values of del w. Del w is basically w2 minus w1. Similarly, the next value would be w3 minus w2, so on and so forth. Once you put them in the cell values in the corresponding columns. So, the columns are not shown here, those particular columns corresponding to the first difference of u's or the second difference of u primes are not shown here. So, once you basically find out the first difference of the of u primes and divide them by the delta w, you will basically have the u double prime, put them in the formula which is minus u double prime by uw, you find out a values. So, if you find out the a values are coming out to be constant, then finding out a prime would obviously be 0, which basically corroborates with our actual set of information which is given for this utility function, which we just have covered in the last slide. The value comes out to be 0. Correspondingly, we find out r is basically minus w into u double prime by u prime, put them in the equation and find out. That means we do the same steps as we did for a and a prime, only that change would be you are multiplying by the value of w. So, once you find out r, you find out the values of r prime. R prime comes out to be constant, which is a as per the formula. So, it basically has an increasing relative risk aversion property. Now, let us draw these curves. So, these curves if you remember, a is positive, which is and with a negative sign, it will basically be an exponential function, but it will be decreasing. So, I will again just highlight it using the color green. So, this is the pink one graph where I am just now highlighting is the utility function, which is here. Similarly, you will have the yellow color, which is given here. I am not highlighting, but I am just pointing out this is the utility function, the a value for the utility function. Then the greenish blue one is the a prime, then the violet one is R, and again the brown colored is R prime. So, for all these graphs, again we have the fourth graph also. For all these graphs, I am using the same color scheme in order to make you understand. So, it is my earnest request, please at least for this first week of lectures, before you solve the problems whatever is given, please draw these graphs in order to make you understand that what are the utility functions and what is the significance of A and R, and corresponding to that what is the significance of A prime and R prime. Now, let us come finally to the power utility function. The C values can be taken as positive, negative depending on the problem. I am not going to the nitty gritties of that, I am just giving you a feel of how you can find out the characteristics of the utility function. So, find out you first find out u prime, then you find out u double prime, put them in the equation, and then you find out with obviously with the minus sign, that is minus of u double prime by u prime will give you the A value. Differentiate again with respect to w. So, whenever I am using the word differentiation for all these problems, it is differentiation with respect to the variable which is w, which is the wealth. So, once you differentiate A, you find out A prime, it comes out to be minus bracket C minus 1 by w square. So, w square obviously is positive, if C is positive greater than 1, you will have basically A prime as positive. If it is less than 1, obviously it will be negative. So, you will have basically decreasing absolute risk aversion property. So, here we and actually it would be. So, we can immediately comment that there is a decreasing absolute risk aversion property, and this and along with the fact that when we find out R and R prime, the R prime value comes out to be 0. So, it will be it will basically have a constant relative risk aversion property. So, with these two properties for absolute risk aversion property and relative risk aversion property, which is given as decreasing absolute risk aversion property and constant relative risk aversion property, you can immediately point to the fact that the utility function would be power utility function. Similarly, as I mentioned, depending on these combinations of R prime and A prime whatever you have, you can find out the unique utility function based on which you can work. So, now let us go to the last stage of the utility function, which is the fourth utility function, which is to basically find out the values corresponding to some hypothetical values of w and plot the utility function graph. Again we follow the same procedure, plot the values of w in the first column, then in the second column you have the values of uw depending on the C values which you take. In the third and fourth column which is not given, you basically find out u difference of u, that means the differences, corresponding differences of the values in the cells for the second column. Then you find out in the fourth column the corresponding difference in the cell values corresponding to the fact that it is for the first column, which is basically w2 minus w1, w3 minus w2, so on and so forth. Divide the corresponding cell values of the third and the fourth column, you get basically u prime. Similarly, you find out the difference of the u prime values and divide those corresponding values with w difference or del w, you get u double prime. Once u prime and u double prime are found out, you immediately know, put in the formula, find out A, find out A prime. That means A prime would again be calculated in the same way that you find out the first difference of A divided by the first difference of w, that is del A by del w. Once you plot it, the A values are A prime values are given here in this the slide number 53 is given in the fourth column. Similarly, you go into the next step, find out given A, you find out R, which is given in the second last column, and then again find out the difference of R divided by the difference of W, which is del R by del W will give you the values of R prime. So, R prime you find out is 0, is exactly matches with what are the calculations we have done, and based on that you can basically immediately comment that what are the absolute risk aversion property, what are the relative risk aversion property. Based on that you can comment is a power utility function. So, let us draw it. So, again I follow the same scheme in the same set of information which I have. You plot this, I am doing each time, but I did not mention it. So, what you do is that plot the values of w on the x axis, the values of u, a prime, r prime. You can have drawn in 5 different Excel sheets, but I just merged them together in order to make you understand. Obviously, it is not cluttered. If you can zoom in and when you draw it, zoom in and zoom out, you can have a much better feel that how the graphs look like for different values of w. So, the values of uw is given by the pink curve, which is this. Similarly, the values of a prime, r and r prime are respectively given by the colors of yellow, which is this one. I am not highlighting, just following the pointer. Then the bluish green one is the a prime, and the r and r prime, which are colored as violet and brown, are given here. So, you can basically find out using the graphs the properties of all the 4 utility functions. Whatever utility functions you can have, follow this simple concept of trying to basically plot the value of given any hypothetical values of w, plot u, then plot from the find out the value the plot means mark the values of u prime, mark the values of u double prime, then going to find out the using these values of u prime and u double prime, you find out a, then find out a prime, then proceed to find out r and plot and find out the value r prime, plot them and basically pass your comments accordingly. So, you are basically double checking whatever you have done mathematically using simple derivatives, which you have already done. Now, let us go into very simple examples. So, these are the examples which I am talking about. So, but I will again repeat, please draw this Excel sheet in order to make yourself accustomed with the way how the utility functions look like depending on the different values of the parameters, which is a, c or whatever there is, or b, which are there for different of the utility functions. Technically, for the quadratic utility function, you will have the parameters. If it is a quadratic equation, you will have basically a, b, c. Similarly, for the exponential one utility function, you will have the parameter a. For the power utility functions, you had the parameter of c. So, depending on the change and also on their range to between which value to which value they can change, you can plot the values and look like how the utility functions themselves look like depending on the different parameter values. Now, suppose the utility function is given as w to the power 0.25, which is w to the power 1/4, and we are required to find the properties of the utility function and also draw the utility function graph. I have not drawn the graph, but I am just going through the simple calculation. Find out u prime comes out to 1/4 w to the power minus 3/4. Hence, we have proved as per the first property of non-cessation that the u prime value is greater than 0, because 1/4 is positive, w is also positive, w to the power any higher negative value would be 1 by that w value. So, it will be 1 by w to the power minus not minus 3/4. So, w being positive, obviously this would always be positive. The main question is whether that increase in the u prime value is happening at an increasing rate or a constant rate or at a decreasing rate. Based on that, we can comment whether the person loves risk, whether the person is indifferent to risk, or whether the person hates risks. Now, we find out u double prime. The u double prime value comes out with the minus value, minus 3/16 w to the power minus 7/4. So, 3/16 is positive, w to the power minus 7/4 is also positive. So, it is negative. Hence, the utility functions has two fundamental properties of non-cessation and risk aversion properties is basically agreed upon. So, with this I will end this 5th lecture. That means we complete our first week of classes, and the examination or the assignments which would be there, sorry, not the examination, the assignments would be there would be based on the simple problems of trying to find out the utilities, very simple problems. But again I will stress the fact that please read the concept of the utilities, the books which are already being discussed in the website which is there, and I have discussed that the syllabus which is already given. These are a little bit on the higher level, but there are definitely very simple economics books from which you can get the concept of utilities, and based on that brush up your concepts if you know, do the problems, solve the assignments, and once the utility function is concept is over, which I think should be over by within 1 or 2 lectures in the second week, we will start the concepts of different type of multi-criteria decision making, multi-attribute utility theory, and then proceed with the actual content for DADM2. Have a nice day and thank you very much for your attention.